All right, welcome to Chapter 12, Section 5, called Volumes of Pyramids and Cones. This is for Integrated Math 2 or IM2. So I'm going to be reusing some of these videos from a previous video, so the problem numbers may not quite match up, although you will see a title at the bottom to let you know which number it's supposed to be. It's just kind of a time saver there. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too. If there's more than one answer within the question, there's partial on there too. Down here it says, please remember, once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the grade book when you click that button, so that your teacher can see what you've been working on, and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Make sure you read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. All right, so in this one, it says find the volume of this rectangular pyramid. Be sure to include the correct unit in your answer. So this one would definitely have some background information, at least a formula. We dealt with this in the last video, where we kind of learned that a lot of these volume formulas come from exactly the same thing, where it's volume equals base times height. And that's for a prism. And a prism is just simply kind of a box shape, right? We can have kind of a plain one where it's a rectangle or a cube, of what we kind of think of like a regular box. But you can also have a triangular prism where instead of the bases being squares or rectangles, they're triangles. And then we also did cylinder on the last video as well. So these all use the same idea. This is just the area of the base. Area of the base. So we're going to do the same thing on this one. The only difference is we're going to have it multiplied by 1/3 or divide by 3. Means the same thing. But we're still going to do base times height for the pyramid. And what this means is if I had a rectangular prism, so I actually had the full box here, it would hold 3 times more than the pyramid holds. So we're dividing it in half. The pyramid holds 1/3 of what a rectangular prism would hold. So if I actually drew inside of here, I don't know how nice this will look, but I'll kind of draw a pyramid. It has to have the same height though. So it'd have to come up to here like this. So a pyramid, it's rectangular like this. So it's the same height and it has the same base, but all of this space here and even in the front here that we can't see, we wouldn't be using that. So if I were to like fill it with liquid, then all of that space would not be able to be filled up anymore because we're kind of chopping it off with the pyramid. So it's just kind of a visual there. So it's 1/3 base times height when we're talking about a pyramid. It's 1/3 of the prism. All right, so now that I've gone over that, still we have the base, so we need to make sure we're looking at the base. It's a rectangle, so in order to do that, I have volume equals 1/3 the base of a rectangle. To find the area is length times width. So I would have 5 times 3, because it's the length times width, and then times, I don't know why I put V, that should be an H, height. The height of the pyramid is 8. So now I'm going to go through and I can kind of rearrange this with I'm associating the 5 and the 3 with the parentheses because, you know, I wanted to make sure you knew those were the base here. I'm kind of replacing B with 5 times 3 because the length times width. But the parentheses aren't really necessary, and I can also move them around. So commutative property. So I can multiply 1/3 times 3 before 5, so I can kind of jump over. Well, 1/3 times 3 is actually going to be 1, because it's really saying, well, 3 divided by 3. It's another way of thinking about it. So 5 times 1 is 5, and then 5 times 8, well, that becomes a little easier, right? Because now it's just 40. And then I need to make sure that I choose the correct unit. Remember, it is volume. Volume is always cubed because we're thinking of 3 dimensions. It's a 3D object. So there's length, width, and height to it. So I know it's going to be cubed. And a lot of the time it's going to be the same type of unit. You just have to choose the correct one as far as, is it length, is it area, is it volume? So just make sure you're paying attention on that one. All right, now we're going to look at the volume of a cone. So we did the volume of a cylinder, which had the same idea as this one here. It was volume equals base times height. The base of a cylinder is a circle, right? So if I have a cylinder, I'm going to try to draw this. I'm not very good at drawing cylinders though. I should have done this dotted too because you can't see behind it, but that's okay. So we're going to pretend like that looks like a nice cylinder just for a moment. Hopefully we can kind of picture that. And if I have a cone, it's going to a point and it's going to kind of fill up everything except for, just like the pyramid, we're kind of chopping off pieces of the cylinder there. So instead of it just being base times height, it's also going to be a fraction. And again, if you didn't know, oops, I didn't mean to click that guy. If you didn't know right off the top of your head, that's what the explanation in the example is for. This one is also 1/3. So both pyramid and cones are 1/3 their kind of original shape, if you can think of it that way, the whole shape. So it's a rectangular prism for a pyramid, or a prism, doesn't have to be rectangular. And then a cylinder for a cone. So it's 1/3 base times height. Remember, the base of a cylinder is a circle, so it's going to be pi r squared times height, and then we're bringing the 1/3 down. So this guy is what I'm putting in parentheses. I'm just pointing out that the base is a circle, so it's to find the area is pi r squared. That's a 2. I swear that's a 2. All right, so let's take a look at our cone here. Find the volume of a cone with a height of 9 centimeters and a base radius of 5 centimeters. Use the value 3.14 pi and do not do any rounding. Be sure to include the correct unit in your answer. So no rounding, and we want to make sure we write this out. So it's 3.14 for pi instead of using the pi symbol. The radius is 5. So I'm going to have 5 squared. And then the height is 9. And they gave us our calculator back here, so they randomly kind of give us that back. And I can go 1/3. This one's nice because it'll actually show you the whole thing. So I'm a little wary of typing in fractions in calculators because if you don't do it correctly, it may confuse what you're trying to multiply and divide. So just be careful. If you can actually see it, where you see the fraction like this, perfect. That's definitely going to come out correct. But if you just do 1 divided by 3 times 3.14, sometimes it doesn't always understand what you want. You think that it would kind of just understand exactly what you wanted to do, but it doesn't always understand the order there of how you're typing it in. So just be very careful how you're typing that in. Okay, so we have our 235 and 1/2, and it's going to be centimeters cubed because it's a volume again. So we just want to make sure that we're paying attention to the unit. All right, so that was section 5. I will see you in section 6.